हेलो गाइस, वेलकम यू ऑल टू एआई की पाठशाला। मैं हूं आपका भाई, आपका दोस्त अनूप। सो वी हैव ऑलरेडी स्टार्टेड द पांडास बूट कैंप एंड टुडे इज द फर्स्ट सेशन ऑफ द पांडास बूट कैंप. The last session was just an introductory session, so we do not have covered any concept. That was just an overview. Now, for learning pandas, you do not require very advanced concept of Python. Only the basic understanding of the Python is required. Also, that's why if some of you who have not yet been familiar with the basic concepts of Python, I have attached my playlist of the basic Python and also the advanced Python and NumPy playlist in the description section of the video. So you can first go to that basic concepts, learn it, then you can come back here so that it will be easy for you to understand the things. So moving ahead, before we get into the pandas, let me first introduce you to very important related library, that is NumPy, and the short form of which is a short form for numerical Python. What is this NumPy? NumPy is basically the numerical Python. And let me tell you one more thing. I have already conducted the session of NumPy. So I have, it would be better if you can go through that playlist, NumPy playlist. I will be attaching this playlist, link of that playlist in the description section of the video. So you can go there and watch that playlist. So NumPy is basically a short name for numerical Python. This is called numerical Python. So NumPy is one of the most important scientific computing libraries in Python. It is a scientific computing library. It is like scientific computing library. Just like Pandas, NumPy is also is one of the library of Python, and it is basically used in scientific computation. So that's why it is called scientific computing library. And it's important for us to understand some NumPy because behind the scene, even Pandas that we are going to study depends on NumPy for its own data structure. Depends on NumPy. Pandas also depends on NumPy for its own data structure. So let's take some moment to explore this NumPy. So, and the fundamental data structure in NumPy is called, n-dimensional array. Let me erase this and then let me write it. Fundamental data structure, in NumPy is called n-dimensional array. This is the fundamental data structure of NumPy. Keep on coding along with me. See, first of all, before actually starting the understanding this NumPy and Pandas thing, we have to install this in our system. So for installing this, what you need to do, you have to do pip, pip, right? Yeah, here pip inside your shell. Then you have to write install, 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 and then you have to type NumPy, NUMPY. After writing this, pip install NumPy. Let me select the kernel also. That would be a great. Fine. you have to write pip install numpy. After doing this, you have to run this cell. And when I am running this cell, I am getting requirement already satisfied. And why it is giving me this thing? Because it has already been installed in my system. But if it is not installed in your system, so what it will do? It will first get installed in your system. Then if you will run it for the second time, then it will show you requirement already satisfied. It will take some time, few seconds of time, maybe 10, 20, 50 seconds of time, depending upon your internet speed, and it will get installed. So this is the first requirement that we used to do. Now, after that, you need to install pandas in your system. Same thing you have to do. So for installing the pandas, you have to write pip, then install, and then you have to write pandas, Pandas. Just like NumPy, you have did it. You have to do this same thing with the pandas also. Pip install pandas, and you have to run this. Let's run this. When I am running this, it is again showing me requirement already satisfied. I have already told you because it is already installed in my system, in my environment. So if it is not installed in your environment, it will first install it. So you guys install it. Thereafter, when you will install these two libraries, NumPy and Pandas, inside your environment, in whichever environment you are working, then after that, you have to import it in your program. We already know this, but let me tell you again. For importing these two libraries, simple thing is that you have to write import import pandas, Pandas pandas as PD. What it means? PD is an alias for pandas. What means? Whenever I want to access pandas, I will access through PD. PD is a name given to I have given a name pandas, short name to the pandas, PD. So you have to import it. So when I am doing this, now this panda has got imported in our program. After that, I need to import NumPy also. So what I have to do? I have to write import, then NumPy, NUMPY NumPy as NP. NP is basically an alias for the NumPy. Just like we have used in pandas as PD, we are using for the NumPy, we are using NP. And you have to, these two is imported in our program, pandas and NumPy. Thereafter, what I want, you should check the version of pandas and the version of NumPy which is installed in your system. It might be possible that in some of your cases, you have already installed this NumPy and pandas inside your system, but that is not a latest version. That is maybe some previous version. You must be using some previous version, some old version. So to check the version, you have to write PD for pandas. You have to write PD. Then you have to put dot. Then you have to write underscore, underscore, double underscore. Then you have to write version. And after version, you have to again put double underscore. Then you have to run it. If you will run it, you will get, when I am running this pandas, I am getting 2.0.2. That means right now, this version of pandas is installed in my, is in my program. Fine. Let's see. Similarly, for seeing the version of this NumPy, I have to write np dot underscore underscore version. When I will write this and I will run the program, let's see what happens. If I will run it, I will get this 1.24.3. This is my version that is installed. But I suppose these are not the latest version that is installed in my system. So for installing the latest version of the Python, already Pandas and Numpy is installed, but I do not know whether it is a latest version or it is not a latest version. So I need to upgrade it. So what you need to do? You need to upgrade it. For upgrading, there is one command called pip, pip. Thereafter, you have to write install install install, and thereafter you have to write dash double dash upgrade upgrade upgrade, and then you have to write pandas pandas. Fine. So let's upgrade it. Let's run it. After upgrading it, I have upgraded it pip by using pip install dash dash upgrade, then pandas. So after upgrading it, let me import it once again. So, and one thing is that when I'm upgrading my pandas, then I have to restart my kernel. If I will not restart my kernel, then this will not take the upgraded. Can you see here the message what I am getting? I have already upgraded my pandas, but still to make the upgraded changes available in my program, it is telling me, note, you may need to restart the kernel to use the updated packages. See, package is already upgraded, but for that I need to restart my kernel. So here you can see an option of restarting. So you have to click here. And it is asking, do you want to restart the Jupyter kernel or variables will be lost? I am asking, okay, restart. Fine. If I am asking it to restart, then I have to, after restarting, I have to, what I have to do, I have to import pandas once again. import import pandas, pandas pandas as PD. If I am importing it, I am getting this thing. Fine. And thereafter, if I am importing my pandas, I am getting this. And thereafter, let me check the version of pandas now. PD dot underscore underscore version, this thing, and let me run it. So, what was my previous version of pandas? Can you see 2.0.2 was my previous version of pandas, 2.0.2, and this is my latest version, 2.1.3. This is the latest version of pandas, because earlier the old version was installed, now it has been upgraded to new version. Similarly, to upgrade NumPy also, I have to do the same thing. What I need to do? Pip install underscore underscore NumPy. Pip install underscore underscore upgrade NumPy. So let me upgrade my NumPy also. Pip install, then under dash dash upgrade, and then I have to write NumPy. If I will simply, now it is upgrading. Now what it is again in here, can you see here? It is also, again it is telling me you may need to restart the kernel to use the updated package. So let me restart my kernel once again. Yes, restart. Fine. Thereafter, let me check. I have to again import this. Import numpy as np and let me import pandas here again because the variables are lost. Import pandas as pd and then let me run these two and then let me check the version. So for checking the version of pandas, what you have to do, pd dot underscore underscore version, and for checking the version of numpy, what you have to do, np dot underscore underscore version. So if I will run this, I am getting this version. If I run this, I will getting this version. So can you see earlier the version of my numpy was 1.24.3. This was my earlier version of numpy. And this is my latest version of numpy 1.26.2. Why this is happening? Because I have upgraded my version to the latest version. Earlier, some old version was installed and now this is the latest. If you will go to the official site of Pandas and NumPy, that I will take you there in some time, you can see you can see the message there that this is the latest version of NumPy and this is the 2.1.3 is the latest version of Pandas. Let's first understand what is NumPy. Let me write it here. What is this NumPy? NumPy is basically n-dimensional array. It is also called n-dimensional array. And what is this array? Array is basically it's a collection of similar elements. Collection, C-O-L-L-E-C, collection of elements. Fine. We will understand this array thing and lot of things here. So let me write a simple code here, and I am writing one variable a underscore py Python, and let me write a list here. And inside this list, I am putting some random values inside this list, some random integer values like 10, 60, and let me write 40, 199. Let's write 213. Let's write some other values 1599. Let's say. So this is a list, and we already know that this is a list because we have learned this inside the Python program. In the list concept, we know that this is a list. Let's run this program and let's check the data type of this simple code. Let's check its data type. If you will check the data type of a underscore py, so what you will get? You will get this is a list. Let's see, it is giving me this is a list. Now, let's take another variable b underscore np. And here, let's see what I am doing. Instead of writing the list like this, I am writing np. What is my np? Np is an alias for numpy that we have imported. So np dot array, let's write np dot array, and let's put this list. If you will run this program, and after running this program, if you will see the type of this type of this, so what you will get? and let me access this b underscore np. Let's see what I am getting. I am getting array, and these values are inside this array. And if you will check the type of this, let's check b underscore np. So what you will go get? You will get numpy dot nd array. So can you see, this is my list, a underscore py is my list, and inside this list these are the values, and the similar values I have given inside here while creating a numpy array, and this is a numpy array because I am getting here by checking the type. You can see it is written numpy dot nd array. So both of these things are looking very similar. If I will write here like a underscore py, if let's say access it, and b underscore np, let's access this. If you see both these, it looks very similar, and whatever value is inside this, exactly this value is also inside this. But when I am checking the data type of this, one I am getting as list, this is my list data type, but this is my array data type. The data type of this is numpy.nd array. This is a data type. Although the data type of both are different, but both of these are looking very similar. So what exactly did we achieve here? Why not work with Python lists instead? Because both are looking very similar. After all, both representation look very similar. So
can you go to the previous slide?
So let me just clarify you this. Why instead of this list, many times, instead of this a underscore py, let's say this is a list, many times we are going to use numpy array. And so why we are going to use this? Because applying operations or transformations to numpy array is much quicker. So this is the big benefit. This is the first big benefit. So let me write this thing here, or transformations to numpy arrays is much quicker. So this is the first big benefit of using the numpy. So we will understand this with the help of one example. So there is one, let's say, I am taking one question. And what is my question? My question is, I am demonstrating you how useful this numpy arrays or this numpy is. My question is, multiply all the numbers in the above list by 10. This is my question. So what is my above list? This is my list, a underscore py. So I want to multiply each one of the elements that is present inside this list with 10. This is my question. So now, but let me discuss few approaches to solve this problem. So first, let's discuss this. Let's solve this code with the help of, let's write the code with the help of this Pythonic approach. So let's write one variable a RR, and then let's create one empty list. Thereafter, I am writing for I in a underscore py. So then arr dot append, and thereafter let's write I multiply 10. After that, I am simply just here printing this ARR. So if I am going to run this, let's see what I am getting. I am getting the multiplication of this list. 10 is multiplied. 10 becomes 100, 60 becomes 600, 40 becomes 400. Everything will get multiplied by 10. So I have to write this code in this way. Now, let me discuss the same code. Let me write the same code by some other approach. So if I will use the approach of map and lambda function, let's say, let me write it for more functional approach, more functional approach. For more functional approach, let me write it like lambda. Then after lambda, let me put the after lambda, what I have to write? I, then put this colon, then I multiplied 10, comma, a underscore. So this is a lambda approach. So thereafter, what I want to map this. So let's close this inside this thing. Fine. And after that, let's add map here. So I want to map it with a underscore py. Fine. Thereafter, let's convert this into a list. So for converting this into a list, what you have to simply add list here. So this is one approach to solve this problem, this code. So let's run this. I am getting the same result what I was getting earlier. Now, there is a third way to solve the same code, and this is called list comprehension approach. List comprehension approach. And the list comprehension approach is like I multiply by 10 for I in a underscore py. So let's run this, and I am getting the same output. So these are the three ways of multiplying all the numbers in the above list by 10. Can you see this? This is a normal Pythonic approach to solve this above question, above code. Now, in NumPy, it is as simple as saying that's all we need. Let's see. Let's take b underscore np. b underscore np. What is this b underscore np? A underscore py is my list, and b underscore np is my array. This is my NumPy array, and this is my list. If I want to if I will use the NumPy, and if I simply write b underscore np multiply 10, and if I just print it, I will get the same thing. It is just like saying that's all we need. So can you see how the computation is so much easy and so much fast in case of NumPy? By using the NumPy, we have done the same calculation just like that. And the same calculation what we were doing here, we are taking too much of, we are writing too much of code, we are applying so much of logic, we are applying so much things. But in NumPy, we have just multiplied it by 10, and all the elements present inside this NumPy ND array has been multiplied by 10. This is so much easy to do the things in NumPy. Now, let me take you to the NumPy. Let me just take you to the official page of NumPy. And what it is written, can you see? NumPy 1.26.0 release. This is the latest version of NumPy we are talking about. So there are a lot of things inside this NumPy. Can you see this? Quantum computing, statistical computing, signal processing, image processing, graphs and network, astronomy, cognitive psychology, architecture and engineering, geographical processing, geoscience, mathematical analysis. In all these fields, this NumPy is used. Lot of case studies you can see. First image of black hole, detection of gravitational waves, sports analytics. In all these fields, the application of NumPy you can find. Now let me tell you some of the whatever mathematical things we are doing, you can easily do it in NumPy. These are the documentation, you can see these are the documentation of the NumPy user guide. So inside this NumPy user guide, you will find everything related to the NumPy. What is NumPy, installation, all those things, this broadcasting, copy and views. I have already discussed these things in my NumPy session. So you can go to that session and understand all those things. NumPy not only makes it extremely easy for us to apply transformations, but it also offers a wide range of functions that are otherwise not available in CorePy. There are lot of mathematical functions that is called universal functions or ufunc. UFUNC func is present inside this NumPy. Here you can see array objects, array API standards, universal functions. These are some of the universal functions that are present inside NumPy. If I will scroll down, you will find here lot of functions. There are a lot of methods. There are a lot of functions. For performing a mathematical operations, there are a lot of functions is present. You don't need to remember all these functions. Simply you understand whenever you need to do any kind of mathematical calculation, NumPy is there. You can come, you can search for the right functions and you can use that function in your program and you will just do the calculation in a second. So these are the trigonometric functions present there. So whatever trigonometric calculation you want to do, you can do it by using these NumPy functions. Bit twiddling functions, there are comparison functions. Like that, you will get a lot of things inside it. So this is just, I want to give it a brief idea how this NumPy is and what is there inside it. So see, there are a lot of floating functions and likewise you will get a lot of things inside it. Whatever the ufunc function that we were discussing, these functions are like you can apply that functions directly to NumPy arrays and you will get the result almost instantaneously. That is, it is very, very fast. So the second point is that the another great benefit of working with NumPy is its speed, or you can say its performance. Speed or performance. This is the second most important benefit of working with NumPy. It's speed. Speed, or you can say performance. Performance. This is the second biggest benefit of using NumPy, that you will get a very good speed and you will get a very results in a very quick span of time. So NumPy array, till now you must have understand with the help of these code, NumPy arrays are much more efficient than Python list. And this is because, and a lot of this has to do with how NumPy get stored in memory. This has to do with how NumPy get stored in memory. So let's understand this thing, how NumPy gets stored in memory, and why is there such a huge difference in speed and this thing. So here is a NumPy. This is my NumPy and this is my Python list. So NumPy is why there is a difference in the speed of NumPy and Python list. It has to do with the memory. So what happens is that in NumPy stores its data in contiguous blocks of memory. This is a continuous blocks of memory. That means whatever is there, they are continuously one after the another, they are present in a block. And in NumPy, you will get that all the datas are of homogeneous type. Homogeneous type means all the datas are of the same type. But in case of Python list, this is not true. You know this thing very well. We have already discussed this. In case of Python, the data type of the data that is present inside my Python list may be different. You can have inside a Python list, you can have a string value, an integer value, and a floating point value, or maybe even a list also, even a dictionary also. So here the data type of all the data of different datas are not same. They are different. But here in NumPy, the data type in a NumPy array, all the datas are of the same type. That's why they can be stored in a contiguous blocks of memory, which is to say that all the items in NumPy arrays are next to each other in physical memory. Just like this, let's say this is a physical memory. If let's say this is a physical memory, so all the items that is present in one NumPy array are next to each other. They are next to each other. Whereas in Python list, whereas the Python lists do things a little bit differently. Instead of this data itself, what happens is that Python list stores pointers to the data, which is also a kind of addresses for where the data is located. If inside a Python, if there is some list, so these are the pointers. This is the memory, and there is some address, and this is the address. There is some can you see this pointer? This is a pointer to the memory. This is the data itself is not getting stored in the memory, like it is stored in some variable, and that variable get pointed towards that location which is present in the memory. You will get to understand this more clearly as we will move ahead. So there is a, if let's say, let me give you one example. If inside this Python list, if you write a is equal to, let's say, 5. So what happens is that you are creating one object inside this memory. Let's say you are creating one object inside this memory, and this variable is pointing towards that memory. This is not actually present there, but it is pointing to, it is referring to that memory. So this is the difference between the way Python list stores data inside the memory and the array stores data inside this memory. So there is a level of indirectness and overhead with the way Python lists stores data information, and these results in worse performance, which becomes even more noticeable as the size of the array increases. As the size of the array increases, you can notice this more clearly. In Python, let's say you use a variable to store and reference the data. What I have told you, when we create a variable and assign a value to it, like here, Python creates an object in memory. Let's say it has created some object in memory to represent that value. This value is not actually present, but the representation of the value is present. And each object, the object that it has created inside the memory, each object has a unique identifier. Each object has a unique identifier. Each object in memory has a unique identifier. That is, it has a unique type and a value associated with it. And what is this identifier? Identifier is a reference to the memory location where the object is stored. It is a identifier is a basically what, let me write, a reference, reference, reference to the this is a reference to the memory location, to the memory location where the object is stored. So you may ask, why is this the case? Is NumPy just smarter about the way it stores data? I can say not necessarily. You say, what NumPy achieves here is the ability to store data in contiguous blocks of memory. As a result of this trade-off, and that trade-off is that within a given NumPy arrays, you could only store one type of data or one data type, that is one type of data. And this is not true in case of list. In case of list, you can store a different type of data. So this performance is the result of a trade-off. And what is this trade-off? This trade-off is, do you understand the meaning of trade-off? Let me also explain you the meaning of trade-off. So in case of this NumPy array, it is a result of this trade-off. What the meaning of trade-off? Trade-off is like, you can understand it like this. A trade-off is a situation in which you have to give up one thing in order to get another thing. It is a decision that involves making a compromise between two or more options, each with its own advantages and disadvantages. In simple terms, you can say a trade-off is where one thing increases and the other thing must decrease. For example, let me give you one example. Let's say when you buy a car, a new car, let's say you buy a new car. So now you have to trade off between fuel efficiency, FE means fuel efficiency, and performance. Let's say you have to make the trade-off between fuel efficiency and performance. So what will be the trade-off? A fuel efficient car, a car which is fuel efficient, will get better mileage. That means if a car is a fuel efficient car, so you will get a better mileage in that car. So, but it may not be as powerful, or it may not have as many features as a less fuel efficient car is having. So this is a trade-off. If you are buying a fuel efficient car, so you will get a good mileage, but that car may not be as powerful as a less fuel efficient car will be. And maybe that a fuel efficient car may not have many features and a less fuel efficient car is having a lot of features. So there's nothing right or wrong here. This is something called a trade-off. You are compromising something for something else. So this is what NumPy is doing, a compromise by storing the data in a contiguous block of memory. Contiguous block of memory. Fine. Now let's understand this a little bit more profoundly with the help of some code. So let me write it here so that simple array of integers. Simple array of integers. Fine. Now let me write one code here. C underscore, let me write C underscore variable NP, and let's write one array NP dot array array, and inside this let's pass a list 1, 2, 3. Simple. And if I run this, what I'm getting? Fine. Now let's check the data type. C underscore NP dot D type. This is a way to check the data type. And if I will run it, I will get the data type as int64. Fine. That means we can also see it visually that whatever elements present inside this list, I have given only the integer value, supplied only the integer value, and I am getting the data type as int64. This is fine. Now, what it means, each one of these numbers is stored as 64 bit. And what is its bit? It's in a, that is 64 bits in a contiguous block of memory. So that means they are all right next to each other in the memory location. Let's say, let me explain you this thing. Let's say inside the memory where these 3 values are present, they are all present next to each other. If 1 is present here, 2 is present here, 3 is present here, and the data type of all these 3 are same. So that's why they are located in a contiguous block of memory. This is a contiguous block of memory, and they are right next to each other. They are right next to each other here. Fine. Now what happens if you can go in and change one of these numbers to the floating point number. So let's do it. So let's go and change it. Let me change this thing. Now what I am doing, I am simply copying this code, and here instead of this 2, I am writing 2.0. So what I have done, basically inside this array, I have changed one value into a floating point value. And now let's run this. And now let's see C underscore NP. Let's see what I am getting. Can you see all the values inside it get changed to floating point number? And if I will check the data type of this, C underscore CP, C underscore NP dot D type dot D T D T Y P E type. If I will do this, I will get float 64. Now, what I am trying to explain you here is, see what is happening here. NumPy realizes that now, let me first open by this thing. NumPy realizes that now it's dealing with a floating point number, as well as when I am passing this thing to NumPy, this NumPy realizes that it is dealing with floating point number and two integer. Now, these three are two different data types, but NumPy cannot store different kind of data. It can only store the same kind of data. So, NumPy understands these are two different data types, so they could not be stored together in a memory. Since these are two different type of data, one data is a floating point data and the other two data is an integer data. Since they are two different data type, so we cannot store them in a contiguous block of memory, like in a list. So what happens? So what NumPy does here, that it decides to store each item, as in all the three numbers including the integers, to store them as floating point numbers, that is float 64. So what it is doing, it is storing all the values, it is automatically converting all the values into a floating point number. That's why when I am finally executing this, I am getting all the values as a floating point value. Even this integer value 3 and 1 has been converted into this floating point value. And when I am checking the type, I am getting this float 64. This is known as implicit upcasting. This is known as implicit upcasting. Implicit upcasting. UP up, CASTING. Why this is known as implicit upcasting? It's upcasting because we are going from int. First, it is upcasting because we are going from int to float, because the two values that was in the integer has been converted into float. So it is upcasting. So value is going from integer to float. That's why it is an upcasting, and therefore we are increasing the precision, and it's implicit because, and why this is called implicit? It is implicit because NumPy is doing this thing. NumPy is doing this automatically. NumPy is not asking anyone. It is doing itself automatically. Since it is doing it itself automatically, that's why it is called implicit. And since it is upgrading from integer to float, that's why it is called upcasting. So, all right, So we see here how NumPy has to work within the confines, within the limit of its restriction that it imposes. And all items should be of same data type. All items inside the NumPy should be of same data type. So that, why they should be of same data type? Because they should, so that they are stored together in a memory. And this restriction to one data type allows NumPy to make very rapid calculation. This restriction, let me write it here. This restriction to one data type allows NumPy to make very rapid computations. So one of the reason of the performance of NumPy has to do with the way data is stored. And another reason for is called vectorization. Let me write it, vectorization. This was one of the reason, and this is a second reason, vectorization. So we will study this vectorization in the coming session. Today we are not going to study, but we will going to study this. This is the second reason. All right. And by the way, with Python lists, we don't have this restriction. We can create a list and store anything that we want. In case of NumPy, this is one restriction, but in case of list, there is no such restriction. Let me show you this thing here also. Let me create one list. We have already learned these things in the basics Python, but let me show you here. Let's create one list and write different kind of data. So this is my int data. This is, let's say, my float data. This is again my int data. And let's create one string data. This is my Anup is my string data. And inside this, let's create one dictionary also. So let's create this dictionary as bootcamp. Let's write bootcamp. And after that, let's add some called, this is a Pandas Bootcamp. So let's write Pandas here, Pandas, Pandas. So if I will run this simply, I'm getting all those things. So this is a list, and inside this list, we can have any type of data, whatever type of data it is. So because of this thing, the speed of list is less than the speed of NumPy. So there is nothing wrong or special going on here, because Python list simply source pointer or references for each one of the objects in memory. So what is happening here? This Python list stores the references for each one of these objects in memory. What is actually happening? We are not storing the actual data. Remember, we are not, in case of the list, we are not storing the actual data inside the memory. We are storing simply the pointers to that data. So this actual data is not getting stored in case of list. In case of list, we are storing the pointers to that data. Pointers, or you can say references also to the data in memory. Pointers to the data, or you can also say references to the data in the memory. So which is also kind of address. So let's say if this is some block of memory, and here is my some lists, and we have one integer data, one floating point data, one, let's say, string data, something like this. So let's say this is also pointing here, and this may also point here. This is a, let's say, floating point, this may point somewhere here. So what is happening? It is for the same type of data, they are allocating the same pointers. It may happen in case of list. So we have seen NumPy. This is the introduction to NumPy, and this introduction to NumPy has been very comprehensive, I can say. Ultimately, this is a Pandas Bootcamp, but I wanted you to get familiar with some of the key concepts in NumPy, because the two libraries really go hand in hand as we move on in our data science and analysis journey. And we find ourselves using a lot of this fundamental NumPy concepts as we move ahead. So in this Pandas Bootcamp, we use NumPy from time to time to create, transform, and manipulate tabular data. We will also occasionally use NumPy universal functions that I have already shown you, as well as other functionality that we will introduce and cover in detail as and when we need it. You can subscribe to this channel and put the comment, and you can refer to your friends or any one of you whom you know that who wants to study free of cost. So he can also join my live session. And for joining the live session, I will you can go to the description section of the video and join my Telegram, subscribe my Telegram channel from there, and I will post all the live session links in my Telegram channel. So that's all. Thank you. Thanks for joining. Keep learning, keep enjoying. फिर मिलते हैं. आपका भाई, आपका दोस्त अनूप.